So this is what the first one should have looked like, okay? First, obviously your vertical, first thing you want to do is check to see if it can cancel out. Nothing's going to cancel. So there's no holes. And then vertical asymptote comes from the denominator, x equals 2, x equals negative 2. Don't forget the x's. Horizontal asymptote, they're both the same exponent, so it's the leading coefficient, which is negative 2. Again, you need the y equals negative 2. Don't forget that. There's a 0 at 2, and the multiplicity is actually 2. You don't need to include it there, but that does help you know that it's going to bounce at 2. And then the y-intercept is 0, 0. Remember, the zeros are a list, and the intercepts are in coordinate point form. Domain goes negative infinity to negative 2, union negative 2 to positive 2, union 2 to positive infinity. There's no holes and there's no slant asymptote. So once you get the actual, from the information we just found, you could have done your vertical asymptotes, your horizontal asymptote, and then the 0 here was the only other piece of information that you had, which means you got to plug in some additional points. You do know it bounces, and usually it bounces away from the horizontal asymptote, but not always. Usually just the cubic ones cross through, but not always. So you want to make sure you plug in points. Like if you plug in positive 3, which is down here, then you get negative 3 and 3/2, or 3/5, that tells you it's down here. And then if you plug in negative 3, you get the same negative 3 and 3/5. This is also something that's symmetric. So if you test for symmetry and you find that it's symmetric to the y-axis, you know that the left side's going to flip over the right. The parabola is never pointing the same direction as the other curves. So once you've found that these curves went this way, you should be able to know that your parabola is pointing up or vice versa. Questions on that one? So some of you made that curve like a cubic curve in the middle. Be careful. You got to make sure you're testing the points. The second one looks like this. So this time there's a hole. If you factor out the top, it's the difference 2 squares, and you can cancel out your x minus 3s. So by canceling it out, you're creating a hole where x is 3. So there's a hole there. If you do need an exact point to get the circle, so when you plug the 3 back in, you find that it would be at 3, 6. That's where the hole should be. So that's where your open circle should be. Once you cancel it out, your new function is y equals x plus 3, which is actually a line. So instead of it being curves, it's a line. And on the spot where your hole is an open dot. So you want to make sure you can graph your line, but you want to also make sure that that open dot is there. Because the x minus 3 is gone, 3 is not a 0. Only 0 is negative 3. Your y-intercept is 0, 3. Your domain is negative infinity to 3, union 3 to positive infinity. These are all parentheses now. And then there's no asymptotes. And again, there's a hole. Jose. Because x minus 3 is what you crossed out. So if you solve that, it's equal to 3. Questions? You know what? I'm going to tell you to put the hole in coordinate point form because you have to find it anyways. So go ahead and put your hole in coordinate point form because you're going to be forced to find me anyways. So the hole is at where x is 3 and then the y is 6. All right, this is the third one. So this time you're going to factor your numerator, which is 2x minus 5 times x minus 1. And then it goes over x minus 3. Nothing's going to cancel, so there's no holes. Okay, vertical asymptotes come from your denominator. So that's x minus 3 equals 0. And the vertical asymptote is x equals 3. Your horizontal asymptotes this time, the one in the top is 1 more than one in the bottom, which means no horizontal asymptote, but there is a slant. So you're going to take the numerator, divide it by the denominator. You can actually use synthetic this time. You're going to disregard the remainder and get that your slant asymptote is y equals 2x minus 1. Your zeros come from your numerator. Solve those, and you get 5/2 and 1. Your y-intercept, you plug 0 in for x, and you get 0, negative 5/3. So then when you go to graph that information, you've got your slant asymptote, which is here. You've got your vertical asymptote, which is here. And you actually had 2 zeros, which were both there, which means that curve goes there. Remember, they go opposite corners all the time. They're never next to each other. So you can plot an additional point. Like I plotted 4, which is down here, and got this curve. But if you're 100% certain on those zeros, then you can just assume that it's going to be in that opposite corner. So depending on how your time is going, you want to do something like that. Okay, this is the last one. So again, you can factor the denominator this time. Nothing's going to cancel, which means there's no holes. You set your denominator equal to 0 to get your horizontal or your vertical asymptotes, and that's x equals -4 and x equals +4. Then your exponents in the top, one's less than the one in the bottom, which means that you have a horizontal asymptote at y equals 0, which also means no slant asymptote. We already said no holes. Okay, solve your numerator, and you get the 0 is -3. Plug in your 0 for your y-intercept, and you get 0, -3/16. Domain goes -∞ to -4, then -4 to 4, and then 4 to +infinity. So you're going to graph your vertical asymptotes. You're going to graph your horizontal asymptote. This time your 0 actually was on your horizontal asymptote. This is how you know it's going to cross through. Okay, but you also want to plug in points. So I plugged in this point, and found my curves go top right, bottom left, and then take that cubic shape through the middle. If you don't know what the shape looks like, you're going to have to plug in some extra points. So don't be lazy. Don't try to avoid that. You're going to have to plug them in. I posted your test review yesterday. Remember, test is Thursday. But just a quick review of the concepts. It's 2-4, 2-5, which is what was on your quiz. All the things involving complex numbers. So this is adding, subtracting, multiplying, rationalizing, quadratic formula with an I. Okay, then we got into 2-5, which is your zeros involving I. If I gave you the roots, you had to work backwards to get the equation. All of that's on the quiz review video if you need to see something worked out. And it's also on your review. And then what we literally just did, which is 2-6 and 2-7. So about half your test comes from what your quiz was, which I'll give back to you tomorrow. And the other half is coming from literally what we just did. Okay. The test reviews there's a lot of graphing examples. You don't need to do all of them, okay? Just make sure that you can do all of them. Any questions for me? Okay.